Our focus is on positive orientation. So what is positive orientation? It is the direction in which a parametric curve is generated as the parameter increases. It is called the positive orientation of the curve. And it is usually indicated by some arrows on the curve. Let's talk about parametric equations for a line. The equations in the form that x is equal to x sub 0 plus at and y is equal to y sub 0 plus bt, while t ranges between negative infinity to infinity, where x sub 0, y sub 0, a, and b are constants, and a is not equal to 0, describe a line with slope b over a, and it passing through the point x sub 0, y sub 0. So please pay attention here. You have a times t, and you have b times t, and the slope of the line is b over a. If a is equal to 0 and b is non-zero, then the line is a vertical line. Okay, let us take a look at a couple of examples. Question says, find two pairs of parametric equations for the line with slope a third that passes through the point 2 and 1. Very good. So we have the slope, which is 1 divided by 3. We're going to use the general parametric equations of a line. X is equal to x sub 0 plus at, and y is equal to y sub 0 plus bt. Well, the slope of the line given here is 1/3, so we're going to choose a to be 3 and b equals to 1. Set x sub 0 equals to 2 and y sub 0 equals to 1. The parametric equations for the line can be written as x is 2 plus 3t, and y is 1 plus 1t, or just t. When t is ranging between negative infinity to positive infinity, the line passes through the point 2 and 1, where t is equal to 0. So when t is 0, x becomes 2, and when t is equal to 0, y becomes 1. And it rises to the right as t increases. Notice that other choices for a and b also work. For example, you can take a to be -6 and b to be -2. And you can write the equation as x equals to 2 minus 6t and y equals to 1 minus 2t. T ranges between negative infinity to infinity. So we don't have a unique representation. These all represent the equation of the line with slope a third passing through the point 2 and 1. Perfect. Question says, find parametric equations for the line segment starting at the point 4 and 7 and ending at the point 2 and -3. So you have the starting point and you have the terminal point. Well, as you remember, the slope of the line is the difference between y values. So you have 7 minus -3 divided by the difference in x values, which is 4 minus 2. Make sure to follow the order. So slope of the line is 5. Notice that when the line segment is transversed from P to Q, both x and y are start decreasing. The direction in which the line segment is generated, so let A to be -1 and B to be -5. So when you do the division, you get a +5. Since P, which is the starting point 4 and 7, is a starting point for the line segment, we can choose x sub 0 to be exactly 4. So y sub 0 is equal to 7. Perfect. So we have all the information that we need. X is equal to 4 minus 1 times t, or 4 minus t, and y is 7 minus 5t. Please note that when t is equal to 0, the starting point is just 4 and 7, which is expected. Because the equation describes a line segment, the interval for t must be restricted as well. So you have a starting point and you have an ending point. What value of t corresponds to the endpoint of the line segment? If you set x, which is 4 minus t equals to 2, we can find t to be 2. You can also check that if you set y equals to -3 or 7 minus 5t equals to -3, we get t equals to 2. Very good. So with the information that we are having, we can basically write down the equation of the line segment as x equals to 4 minus t and y equals to 7 minus 5t, and t ranges between 0 and 2 inclusive. This is the behavior of your line, which is basically a line segment. So it has a starting point and you have an ending point, and the line starts. If you look at the direction is on the opposite side. Our next topic is about parametric equations of curves. The segment of parabola y equals to 9 minus x squared, when x is between -1 and 3 inclusive. How do we represent this guy using parametric equation? The simplest way to represent a curve like y equals to f of x parametrically is to set x equals to t. So your y becomes f of t. Then we talk about the interval as well. Using this approach, if your x is equal to parameter t, your y becomes 9 minus t squared, and t ranges between -1 and 3 because t and x are both the same thing. You can basically graph this as well at starting value. When t is -1, you have the starting point, and when t is equal to 3, you have the end point, and this is the piece of curve represented parametrically. This representation is not unique. Remember that you can use different parameters. You can set x to be 1 minus t, and y becomes 9 minus x squared, which is 1 minus t to the second power. And now, if you solve for t, t is ranging between -2 and 2. So remember that your x is bounded between -1 and 3. So now 1 minus t is in between -1 and 3. If you solve for t, t bounded between -2 and 2. So the whole point is for you to understand this representation is not unique. You can represent this curve using this parameter here, x equals to t, and y is equal to 9 minus t squared, or you can set x equals to 1 minus t, and your y becomes 9 minus 1 minus t to the second power. You can simplify this or leave it as it is. The most important part is when t is bounded between -1 and 3, when x is equal to t, is going to change if you set x to be 1 minus t. Now your t is bounded between -2 and 2, not -1 and 3.